Hey guys, welcome to day 4. We are going to do our quiz review, and then after that you guys are going to take a quiz. Remember, on that quiz it is a one time only. It's not like the concept checks, so that means you only get one attempt to do well on it. Alright, so let's look at the quiz review. The first whole page actually has the same directions. The directions are: identify each of the following as linear, exponential, or quadratic. So we're going to look at graphs first. So we see we got 6 graphs here, and we're going to figure out, are they linear, exponential, or quadratic? So let's just remind ourselves, a linear function is going to be a straight line. An exponential function is going to be a curved line, so a line that has a bend in it. And a quadratic is a U, either opening up or opening down, which is called a parabola. All right, so that's what we're really looking for. So let's just start with linear. So I'm looking for which of these graphs is a straight line. So this is not a straight line, not a straight line. This one is in fact a straight line. So this is linear. And then not a straight line, not a straight line, but this one is a straight line. So this one is also linear. Okay, so we had 2 of the graphs that were linear functions. Now let's look for exponential. So which of the functions that are left are a line that is curved, so a line that has a bend in it? Okay, not necessarily a U, okay, because remember, a U is going to be quadratic, and if it's easier for you to go and identify the quadratics first, then identify those first. So I'm looking, this one looks like it could have been a straight line, but it definitely has a curve or a bend in it. So this one is exponential. This one is not a curved line because it goes in 2 separate directions. It's going up and then it's going down. So it's increasing and then decreasing. So we're going to see this one is in fact our U shape. So that means it's going to be quadratic. Okay, down here, this one is another U shape. This one's going down, so it's decreasing, and then it's increasing, it's going up. So this one is a quadratic. And this one looks like it could have been a line that's been bent here in the middle, so this one is an exponential. Okay, so please remember, you need to make sure that you can look at a graph and identify which of those 3 types of function it is. Is it linear, exponential, or quadratic? All right, let's move down our paper and look at our equations. So we need to be able to recognize which equation is linear, which equations are exponential, and which equations are quadratic. So for me, I like to start with the exponentials because for me, they're the easiest to identify. So let's just make sure, I'm going to write a little note. So our exponential functions have the x as the exponent. All right, so the x is the exponent. So if I'm looking, the exponent here is a 2. This one doesn't have an exponent. This one, here's my little exponent. It's an x, so that fits my rule. The x is the exponent, so this is exponential. Okay, looking down here, I don't see an exponent. Looking here, oh, there's my exponent, and it's an x. Okay, so this is exponential. And then this one has 2. All right, so that's what I like to do first, is the exponential. Identify which functions have an x in the exponent. That means it's an exponential function. So if we graphed it, it would be a curved line. Okay. The next part that I like to do is I like to go and look at my other equations. So like if we look at this first one here, I'm seeing that I have an exponent that's a 2. So that is my biggest exponent that's written. Here, my biggest exponent that's written is a 1. So that means one of these is going to be a quadratic and the other is going to be a linear. So remember, quadratics have a 2 as the biggest exponent, and linears have a 1 that's the biggest exponent. Okay, So that means this one, we said, had a 2 as our exponent, so that means this one is quadratic. This one has the biggest exponent, that's a 1, so that means this one is linear. Okay, let's do the same thing for 10 and 12. So I'm looking here at number 10. I don't see any exponents. That means that there's an understood 1 on that x. And if I look over here, my biggest exponent is this 2. So that means this one is my linear, because the exponent is a 1. And this one over here is my quadratic, because the exponent is a 2. Okay, so you need to be able to look at a equation and tell whether that is a linear function, a quadratic function, or an exponential function. Okay, then the third way that we need to identify is from a table. Okay, and for tables, what I like to do is I like to identify my quadratics first. The reason I like to do that because a quadratic function is going to have symmetry. Okay, so remember, symmetry means that there's a mirror image. So I'm going to see the numbers repeat themselves on the left side and the right side. So if I'm looking here, and when I'm talking about symmetry, I'm talking about my y's. My y values have symmetry. So if I'm looking here, I got a 0.25, 0.5, 1, 2, 4. None of those repeat each other. So that definitely does not have symmetry. When I'm looking here at 14, I've got a 4, a -2, a -2, and a 4. So I'm looking, I'm like, oh hey, those 4s are repeating, and these -2s repeat. So that means that here is a line of symmetry, so that these are going to mirror each other. So to me, I can say, I know for sure that that right there, that table, is a quadratic. Okay, if I look at this other one, this one does not have symmetry. None of those y values repeat. Okay, the next one that I like to look for is I like to look for linear. Okay, so linear functions, these are going to have a common difference. That just means that I am going to be adding the same thing, so I'm going to have the same slope between every set of numbers. So same slope. All right, that means I need to look at the change in my y values, so the change in the y values divided by the change in the x values. So if we look at this one first, the change here to go from 0.25 to 0.5 is 0.25. The change from 0.5 to 1 is 0.5. The change from 1 to 2 is 1, and the change from 2 to 4 is 2. Okay, so obviously I'm seeing these numbers aren't the same, but I don't want to go just based on that because I need to look at the change in the y over the change in the x. So the change here is 1, the change here is 1, the change here is 2, and I think this is a typo. I think that should be a 3. Sorry guys. And then the change here is a 1. Okay, so we're going to see that if we take each one of those and say the change in my y over the change in my x, that's a 0.25. Then if I do the next change, that is a 0.5 over 1. So I'm noticing already these are not the same number. So I know this is not linear. So let's look down at 15. Okay, on 15, we're going to see the change here from 1 to -3. So I need to go 1 minus what is going to get me to -3. So 1, 0, -1, -2, -3. So that's going to be subtracting 4. Here, okay, same thing. How do I go from -3 to -7? That's another subtracting 4. And here, how do I go from -7 to -11? Again, -4, and from -11 to -15. So we're already seeing that these look the same, but these need to be the same too. So this is increasing by 2 every single time. So that's going to make it nice. So -4 over 2 is a -2. If I do the -4 over the 2, it's a -2. So I'm seeing that these common differences are going to be the same every time. So that means this is the one that's linear. Okay, so as I go back and look at this one, my exponential is going to, this slope, this change in y over the change in x, is going to get bigger and bigger every single time because these are going to exponentially get larger. Now, if these numbers are getting smaller and smaller, then that just means it's a decay instead of a growth. So this one is, the slopes are all different. Okay, so this one here is my exponential. Okay, also you're going to want to make sure that you are well versed at the vocabulary. Okay, so like the vocab for what's a domain, what's a range, what's x-intercept, y-intercept, max, min, intervals of increase, decrease, end behaviors, average rates of change. Be familiar with all those vocab words. Okay, there will be vocab on the quiz, so you need to make sure that you're very comfortable with what those mean. Okay, all right, so number 16, we're talking about domain. The domain of this, these are the x's, so this one's going to go from negative infinity to positive infinity. Okay, so it's how far left this one's going to go, forever, to how far right this one's going to go, which is forever. The range is one that you need to be careful with. It's your y values. The lowest y value that this one's going to go is this -1. So -1, and I'm using a parenthesis because I can't ever reach the -1. That's an asymptote. Okay, and then the highest this one's going to go is up forever towards positive infinity. This does have an x-intercept. It's where we cross the x-axis. So this is at 1, 0. We have our y-intercept here, which is at 0, 1. This one will not have a max or a min because there's arrows on both ends, which just means both the left and the right are going to keep going forever, so this is none. Intervals of increase and decrease. This whole function is getting smaller and smaller every single time, so the whole function is decreasing. So there is no interval of increase. The whole function, every single x value, remember these are x's, are decreasing. All right, our end behaviors as x goes to positive infinity, so that means as we go to the right, the y value here is getting closer and closer to this asymptote at -1. As we go to the left towards negative infinity, I see my y values are going up forever towards infinity. Okay, then here, average rate of change, you've got two different interval types given. So this one says from x equals -1 to x equals 0. So x equals -1 is here, x equals 0 is here. So I just want you to find the slope from the left point to the right point. So this is down 2 over 1. Which is a -2. This one, these are x's, remember, so that means I want you to find the rate of change from 0 to 1. Well, here is where x is 0, here's where x is 1, this is down 1 and over 1. So down 1 over 1, which is a -1. Notice those are not the same. Okay, they're not the same because it wasn't a straight line. It's not constant. That slope is changing all the time. Okay, I'll pause here and I'll do 17 and 18 on the next video.